How's it going, everyone? Gabriel Gonzalez here again, exploring now at this observable, which is one of the abstractions that we have right now on the language, especially JavaScript. But this is not native, unlike Promise. But this is still on a draft from the ECMA script, and for the TC39 commit, which is those files that are take care of what are the abstractions and tools that we need to implement in JavaScript, or at least in ECMAScript 2.6. Let me recap that. So ECMAScript 262, right? Which is the specific name of the language, or this is the language specification, ECMA 262 or ECMAScript, right? So let's get into this. Let's get into this about the observable and specifically the RxJS. This library that was made by some of the smarter folk on Facebook, and from Microsoft, where they initially write that for Java, if I recall that right, and then they poured out to other programming language like C#, and now here on JavaScript. So you have one library to rule them all. So what we have done in the couple past videos is to see how can we now work with our observables, what is an observables, how you can test your observables, and then how you can manipulate data and time in your observables to eventually orchestrate across multiple APIs requests. So for those who are not familiar with observables, just to recap of how do we get here. So the language in itself has now several abstractions that we can work with. Asynchronicity or this concurrency, all of these tasks that happen or tasks that overlaps at a time. And because of that, we look at several of the abstractions or tools available in the language, or others that come from different places or different programming languages. So for example, callbacks and timers, which is not native to JavaScript, they are provided by the web platforms where they are run. So when you write your synchronous programs or your applications in JavaScript, or the anatomy of the JavaScript, at least the JavaScript threads, it's important to at least to recap this, is that it's made of the call stack. First, the global or function execution, that inside of that you have is lexical scope, variable lexical environment or variable environment, and then the call stack is the tracking mechanism of functions to indicate where you are at which line of the code you are currently evaluating. The call stack, the way of how can we now handling asynchronicity using the callback queue or the micro task queue. With the callback queue, you use now timers for that. Again, this is something that is provided by the platform that JavaScript runs, the browser or the server. And the promise is something that is native to the language, and it has more priority than the callback queue. And this is an abstraction that helps us to deal with eventual value, but only one. And we also have the event loop, which is the coordinations between the callback and between the queues and the stack, and the web API or the Node.js API, which is what are the set of functionality that the language can have access depend on the platform, the web or Node.js. This is part of the anatomy of JavaScript. And if you are able to at least to articulate that and to understand that what's going on, and also there are other tools in JavaScript like closures that allow you to now write this synchronous code to provide now interactivity to these web applications. When it comes to deal with this distributed computing or asynchronous stuff or tasks that can take an X amount of time to be completed, aka callbacks. So now we need is a particular approach to deal with this. So callback is one of them. We also look at the trade-off of callbacks, like, hey, we got now inversion control because we're passing a set of instructions to these functions that we hopefully we don't get that functions to run too many times or too few times, too late, too early. Don't solve errors and preserve the state context. And also that is they are not reason about, they are not the way how we as humans plan stuff, right? One after the another, right? In a sequential blocking way. So even though that that doesn't solve the problem, we also look at another abstraction. This is not from JavaScript. This is something that way predates JavaScript, especially from programmers back in the 60 and 70 when they see back then how, at least in the defense sectors, when they started to build this small network, which is something that Grady Butch mentioned, the co-creator of UML, where back in the 60s he worked at a telemetry inter-process system where the idea is they have different mini computers. Well, mini computers were a thing of 32 of them. And now you have to deal with this software that needs to be real time, software that needs to be real time, software that are multi-language, software that are software that are real time, multi-language, that is distributed. So how you can break down now a monolithic application into different parts, and also let me bring this out because this is something important to recap. The Grady, there you go, the evolution of software architecture. And I'm making this quick recap is just to join and condense and articulate all of this idea in the most succinct way possible. Even though that I have dealt with that in the past with all of this distributed computing and how you can build now systems that are real times, that are multi-language. There are also what I need here is the vocabulary. That's what I'm looking.
Mini computers were beginning to be a thing, and so the problems of was pretty cool. We had a little mimeographed document that listed the email address of everybody in the world. I think at that time there were a few thousand people, so we knew who everyone was at the time. It was pretty cool to go back. So the first distributed systems were happening in that domain. Indeed, back to Vandenberg, I worked on a system called the Telemetry Integrated Processing.
The telemetry integrated processes systems. Okay. Telemetry integrated processes system. Wait, what? Academic. Interesting. Integrating telemetry data. Okay. So is this in telemetry? Is this solutions or this solution that you can work at a distance? This telemetry solutions
System, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts,
which is kind of exactly what happened here, especially with JavaScript applications that not only runs on one single computer, but also in several computers, right? So the client and the server. So this is one of the issues that we as now JavaScript developers are facing, right? And now, okay. Okay, so this is one of the issues that we as a software developers we are facing, right? So not only is to build this monolithic application or this small application to provide interactivity to the users, but also these big apps that now needs to is breaking down into different stuff, into different pieces. So you have now this the server part and the client part. So this is, for example, now what React in Next.js, at least React 8.19 and Next.js is actually doing for that. So in our context, in JavaScript, because we look at the anatomy and what are the things that we most of the time we as JavaScript developer does, which is, hey, writing this kind of application, but also we need to actually is dealing with this distributed computing, dealing with all of these different parts, different pieces that happens at different times and places.
Was beginning to emerge as a problem, hadn't reached the commercial sector yet. So,
but right now, it is in the commercial sector. Perhaps in the 60s, there was on the defense department, but now it is in the commercial sector.
The industry, began to see that there were limitations to what one could do with algorithmic decomposition. And so there were these pressures all around to try to attend to the next kinds of software that was distributed.
So, software that are distributed.
Software that was real-time.
Exactly. In this so software that are distributed is that software that can be run now here on the client and on the server, right? Software that are real time if you want to provide some feedback. Right now we can use this WebSocket, or you can use a combination of event server send events with HTTP requests, right?
Software that was multilingual.
This is hey, is this application now is reading in PHP on the server, and then we have to write our application in HTML, CSS, and JavaScript on the client. But now that gap is being, thanks to Ryan Dahl, even though that they have a lot of problems along the way. But now that gap is close to only have one language to rule them all, which is, this is not new to the software engineering. This is also a problem that happened back then, and now we have inherited some of those practice and architectures and abstractions or / tools.
Software that worked on a variety of computers,
And this is, hey, software that now can run is on a Mac or in a Windows or in a Linux, most of the times on a Linux. So this is the reason of why I actually make this quick recap about this, and with thunks, which is one of these abstractions that we inherit from the 60s, is hey, because time is something complex, let's going to get rid of that by now passing everything that a function needs, and then wrap that into a function, so anytime you call that function, you're gonna get that value. If this is now an asynchronous operations, you're gonna pass now a callback, so you get so by the time that is done, you get that value out of that. So thunks solve the problem of to eliminate time as a concerning factor. However, this is not native. We also have is the problem of inversion control. But well, now Promise actually give us that to us because this is now native on the language, and this give us this certainty that is going to solve this eventual value, single eventual values. And they have some sort of abstraction that we can play with this series of or this series of eventual values. All right, but again, it's all of them to work with promises, all of promises that can be now done in parallel. So hey, fire up all of these requests, and by the time that is done, I want to give me is what are those promises that were fulfilled. Give me all of those promises that were fulfilled, or if one of them failed, hey, reject that. So for example, that all, abstraction, methods. The other is all settled, the raise and the any. However, Promise solved the problem of inversion control, but not the non-sequential, non-local problem, which is now generators in combinations with Promise actually provide us. So this is now give us the ability to pause and resume the execution of a function. So unlike now normal functions that they run to completions, now with generators we have the ability to actually is now, as the name suggests, is yield, produce series of events, generate series of events, like in a sequence, infinite sequence, or a fixed sequence, all right? But it is more interesting in terms of now that give us the ability is to control the flow execution of that function. So this generator is just the way of how can we syntactically describe it's a state machines natively in the language that we didn't have that back then. This is something comes from Python's, and before generators we need to use these iterators and callbacks to do that. That require careful programming. But now with generators we have that natively. This gives us is an iterator that is give us the ability to control how we give us the control of getting into this function execution, and then pause and pass control, and at some point in the code you can now resume the execution of that, and then pause and pass control again. So this iterator, which is a design pattern of typically stepping through data, pretty much like in a database, all right? When you say, hey, give me is this 10 elements using the offsets, and then when you call .next, you get is the next 10 elements, and the next 10 elements, and the next 10 element until there is no more. So We also look at how can we implement our async and await using these native tools that the language provide to us, generators and promise, and that was a very interesting stuff, because now you know what are the tools that this language provide to you and how you can play with this. So this is great for single eventual values, right? But what happens when we need to respond to a series of streams of data, right? So if we have now an event source, right, whether it is from the server or from the user, let's say typing, clicking, or any other interactions that are firing up series of events, and we need to get one of those events pass through a series of steps and then distribute that across our system. So how can we do that, and what is the way to model that? Because promise only fire once, only works for one single event, and we will try to work with less as a way to see how we can now receive these collections of elements. But they fell short because we need to think them in terms of the source, the producer, and when we want to consume that, or when we want to subscribe that, the setup and the consumer. So this is now observables. So observables is help us to deal with this series of eventual values, or in this case, data that happens over time. So we can have now these abstractions to deal with that. And because this is not native, as I mentioned earlier, well, we look at the RxJS. That's the reason why I make this entire recap, right? And how now can we create is our observables using RxJS. RxJS is something that, even though that is in a state of flux, at least observables is on that stage. It is taking now inspiration from observables like RxJS, among other libraries. So that's why we look at RxJS. So, for example, we can create now our observables. Remember, observables now are this series of eventual values. Is this abstraction, is this way of modeling, is this data or this unit of data that can happen over time. Get that, apply some sort of steps so we can distribute that in our system. So off is one of the way of how you can create these observables with single values, primitive and objects. From is with promises. Promises, iterators, generators, and array like, as well as from observables. And how we can now is subscribe to those series of events, right? We also look at how can we create that, and the contract of you creating your new observable from scratch, pretty much like promise when you pass the executor function, but here you pass the subscriber function that is going to yield this value with the .next until there is a complete methods or an end or an error for that. So this is cool. This is very, very cool because as we move on to look at other common observables, like from event, it's pretty self-descriptive. It's like, hey, now I'm going to wrap an observable around this event source from events, right? Useful for event listeners. So events are basically the bread and butter of UI. Okay, you optionally can pass these functions to say, hey, this is the only value that I care. Okay, on another interesting method like bind callback, you say, hey, takes any callbacks and turn into an observable. So useful especially for file system operations, right? When you want to understand, when you want to inspect, for example, the data that it comes in, all right? The from fetch, so wrap the fetch API in an observable. So again, we don't have a very specific use case for this. We're gonna see that in later videos. But yeah, we actually code that, we create that for that. And how can we create is a counter, okay, with intervals and timers, right? Which is a great stuff. And the difference between interval and timers is that, hey, these intervals now is going to send a value after an X amount of time, all right? Giving you the notion of a timer, so the interval here. And we have now the timer, which is say, hey, let's go to create an observable that emit after a certain amount of time. And timers can also continue to emit at regular intervals. Well, what is the difference between intervals and timers? Is that, hey, intervals emit, as the name suggests, in an interval at an X amount of time, right? Where now with timers, you can now have much more control about when you start to emit certain amount of data, right? So, and also another important thing is that once you create your observables, and once you subscribe to that, which is creating now a subscription, you also need to unsubscribe to that. Why is this? Because let's say you get into a page, all right, and you are listening for clicking events, all right, and if you go to another page, you navigate to another page, and if you still listen for click events, despite that you don't need that, well, you might cause some memory leak issues. So this is the reason why we unsubscribe to our promises. So in any case, but let's jump to the code, shall we? Okay. Which is, there you go. Operators.
Making streams is fine and good, and we've done some.
Let's get into this. This is operators. Operators.
Stuff with those streams. We have manipulated the DOM predominantly. We've occasionally logged to the console, but as these.
Okay.
And we've done some stuff with those streams. We have manipulated the DOM predominantly. We've occasionally logged to the console. But as these events come through, the ability to do stuff with them is, I think, where we start to find the power of RxJS. So really, when we the ability to do stuff with them, the DOM predominantly, we've occasionally logged to the console. But as these events come through, the ability to do stuff with
as these events comes through, the ability to do stuff with them, or the ability to pass, the ability to pass, as these events come through, the ability to do series of steps, all right, or transformations.
Them is, I think, where
the ability to do series of steps and distribute in our system is where the power of RxJS comes.
We start to find the power of RxJS. So really, when we talk about operators, we're going to talk about this like as effectively a story in 3 parts. Part 1, we're just going to talk about some of the basic like data manipulation operators, right? These are not dissimilar from what you might be familiar with like in Lodash or even on the array prototype. It harkens back to the very beginning of this when I said, when I quoted from the RxJS documentation that RxJS is like Lodash for events. Well, yeah, that also means that like some of the methods like Lodash has are common for RxJS as well. We'll start with these. A lot of them like will seem somewhat familiar, or at least intuitive. But what I want you to pay attention to as we go through is the syntax. The syntax could be slightly different than what you might be used to like on an array. On an array, you can kind of chain the methods as you go through. The concept is the same, but the syntax is going to look slightly different, and for a very good reason I'll kind of explain along the way. So we will kind of start with this kind of Fibonacci sequence right here, right? Now this one, as we kind of, like the question we had earlier, was like this one will go on forever. So if you were to just subscribe to this, you would lock up the main thread and bad things would happen, right? So you would have to do something like this. You'd have to say like, okay, cool, I want a Fibonacci sequence of a certain number.
Yeah, well, when you say well true, it's like, you're evaluating is these values from this, current and next, and you're gonna yield for that. So now you're saying is that, hey, yield the current value, okay? And then the values will become now the next plus the current dot plus next, right? So this is how you can create a Fibonacci here. And this is going to do that until the end, until the heat death of the cosmos. Until the heat death of the cosmos.
Right? So you would have to do something like this. You'd have to say like,
so exactly. So hey, let me do this until some iteration for that.
Okay, cool. I want a Fibonacci sequence of a certain number of iterations and then stop, right? But again, the promise of like RxJS is that we can take these streams and we can choose as the consumer when we want to start and when we want to stop, right? We don't need the interval at the time is defined to know when to stop counting. We'll stop counting when we say we're going to stop counting. We kind of like take that control in our own hands at this point. So every observable on top of of everything else has this thing called a pipe method, and a pipe method takes one or more operators.
Okay, so here we're gonna explore is not the data operations.
They're at least intuitive, but what I want you to pay attention to as we go through is the syntax. The syntax could be slightly different than what you might be familiar with like in Lodash or even on the array prototype. One, we're just going to talk about some of the basic like data manipulation operators, right? These are not dissimilar from what you might be.
We're going to look at the data manipulation operations.
Very good reason. Which like this one will go on forever. So if you were to just subscribe to this, you would lock up the main thread, and bad things would happen, right? So you would have to do something like this. You'd have to say like, okay, cool, I want a Fibonacci sequence of a certain number of iterations and then stop, right? But again, the promise of like RxJS is that we can take these streams and we can choose as the consumer when we want to start and when we want to stop, right? We don't need the interval at the time is defined to know when to stop counting. We'll stop counting when we say we're going to stop counting. We kind of like take that control in our own hands at this point.
So the value proposition of using RxJS to work with streams of data is that we have control of when and what we wanna do some operations. On that.
So every observable, on top of of everything else, has this thing called a pipe method, and a pipe method takes one or more operators, right? And those operators kind of run through one after the other, and each one will manipulate the values that come through and pass it along to the next one. So similar to method chaining, also similar to you've used either pipe or chain in Lodash. In a lot of like functional programming libraries, there is some version of this where you can kind of just take a value and keep moving it along the way, manipulating it over time. Where RxJS gets interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time, or I want to only take every nth value, or like if they're rage clicking on that button, wait until they chill out a little bit, and then we'll go respond like with a request and double a number.
Okay.
Similar, we kind of like take that method, and a pipe method takes one or more operators, right? And those operators kind of run through one after the other, and each one will manipulate the values that come through and pass it along to the next one. So similar to method chaining, also similar to you've used either pipe or chain in Lodash. In a lot of like functional programming libraries, there is some version of this where you can kind of just take a value and keep moving it along the way, manipulating it over time. Where RxJS gets interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time, or I want to only take every nth value, or like if they're rage clicking on that button, wait until they chill out a little bit, and then we'll go respond like with a request in a reasonable fashion before we slam our own API.
Wait until
All
we
of
chill
those
about
kind of
it.
things, giving us the ability to kind of control the flow. So we'll start with some of the basic kind of just operators for manipulating the data. Eventually, we are going to move into some of the ones where we kind of manipulate time a little bit and have rules based on kind of the time-space continuum of what we want to do. And finally, we'll look at some of the ones that allow us to kind of take multiple streams and kind of combine and control them as we go along. So we'll start to play around with this in a second. But if we look, we have this one called take, right? And take will solve that initial problem that we had earlier, right?
Mm-hmm.
Where we had an infinite generator that was going to spit out values forever, right? It can still be its infinite self. We're just basically saying, I'm going to take 10 values from you.
Exactly.
I'm going to subscribe, right?
And then bye-bye.
After that, we're done here. I'm going home, right? And so you can now you don't have to have all that logic in the generator.
I'm done here. We
but you
go
can
home.
have it in whatever is consuming it can choose how many values it wants, and you kind of begin to manipulate, so on and so forth. All right, cool. The other one, its friend, is skip. Skip will skip the first number of values. This one is dangerous with a Fibonacci sequence because it is infinite, so you gotta be careful. We have other ones like take while and skip while, which will very much act like a filter function, where they'll go through and they will take all the values up until you hit 200, or skip for a while and then take 4, so we don't have the infinite problem. And you can see we can chain them. Where it becomes a little bit different is, we'll look at the pop quiz in a second, but I want to, like, this slide's a little bit bigger, so I want to look at the syntax here. Is instead of method chaining, right, you kind of pass them all in as individual functions, right? And even if it doesn't take any arguments, you still call it as a function. That's mostly to keep the syntax and the kind of API content the same. The reason for this is by breaking all the operators out into their own functions that you can import one at a time, you can use tree shaking in your bundling tools, right?
Is pipe then an args function? It will take in arbitrarily many. Or is it one of those?
You can use tree shaking in your bundling tools, right?
Is pipe then an args function? It will take in arbitrarily many. Or is it one of those weird like FP functions that has like a definition for 1 input and 2 and 3 and 4, where you max out eventually?
Into their own functions that you can import one at a time. You can use tree shaking in your bundling tools, right?
Is pipe then an args function? It will take in.
Is this pipe in this function? I barely hear about it.
Right.
Is pipe then an args function? It will take in. Is pipe then an Rx function? It will take in
Yep.
arbitrarily many. Or is it one of those weird like FP functions that has like a definition for 1 input and 2 and 3 and 4, where you max out eventually?
I haven't looked at the types to see where this ends. Like the JavaScript implementation of itself, the JavaScript implementation of it, like will allow for n arguments. Whether like if anyone who's tried to like type a function that takes an unknown amount of arguments has seen that the types are usually just more and more types, right? And if you're using this with TypeScript, you know, each one, like if you return a different value, the next one has to be able to receive it, right? So like you start out with that initial value. In this case, from the Fibonacci sequence, it would be a number, right? If you map it into a string and then you try to do a number thing with it, TypeScript will get very angry with you, and TypeScript will assume when you subscribe you're getting whatever the last thing out of that pipe was. But the actual type definition, my gut says, I've looked at Lodash's, where it is simply, here's a type with 1 argument, here's 2, here's 3.
I just looked and it goes from 1 to 9, so
9.
You can put up to 9.
You can put up to 9 before TypeScript gives up on you. But the JavaScript implementation, you should be able to have effectively an infinite number. I think the only color I'll add to that question is 9 in a row. Like past that, like there's probably a reason they stopped at 9, right? Not to say you won't have things where you have child observables, so on and so forth. But like after 9, you can also break stuff out into functions. You have lots of options. All right, so our pop quiz. This will never emit. Does anyone know why?
There's no consumer.
Example the subscribe. Skip while. No, there is a consumer. The consumer is a subscribe.
We got console log consumer.
Exactly. There's a consumer. But here is skip while and take while. So hey, pipe this. So we're gonna get the single value out of this. Skip while and take while. And say hey, skip while. The value is less than 100, and take a while. And it's because no, there is value. And skip while values. And skip while values are less than 100. All right, so skip them, and then take while. Why is skip while doing? All right, take or skip values as long as certain condition is met. Okay, complete the observable when conditions return false. Complete the observable when the conditions return false. Oh, because the condition is met, so it returned false.
The only color I'll add to that question is observables, so on and so forth. But like this will never emit. Does anyone know
It's
why?
because it emits false.
We got console log consuming it.
Skip while emit false.
We will skip value.
We're not mapping any. We're not materializing any of the values. We're just filtering.
We're filtering to a situation where nothing makes it out alive.
Yeah.
Right? We're skipping values that are under 100, and then we're only taking values. Like, but because it's a pipe, you like both those things. Like there are numbers between 101 and 499, right? But only they basically nothing will make it out into the next one, right? So you have to be very careful that your pipe every value passes the next one. It's not a set of rules that all run in parallel.
Because skip while will say, hey, is the value is less than 100? If it is, great. But
it's each stage, right, only lets a certain number of values through. Cool. All right, there are in parallel only values, like, but because it's a pipe, you like both those things. Like there are numbers between 101 and 499, right? But only they basically nothing will make it out into the next one, right? So you have to be very careful that your pipe every value passes the next one. It's not a set of rules that all run in parallel. It's each stage, right, only lets a certain number of values through. Cool. All right, there are over 100 operators. Some of them are deprecated. Some of them are just variations on the theme. we're not going to talk about all 100 of them. We're going to talk a little bit about some of the common ones, and some of them I will just sprinkle in as we are building things, right? But we can kind of see some of them as we kind of go through. So we've got filter. Filter does exactly
As you see,
what it
yes.
does with arrays. It filters them based on the function. So in this case, only even numbers will be allowed.
Based on the observable?
Map. Who doesn't love a good map? Possibly midway through this workshop, you'll hate map for reasons that we will talk about later. Some people who have a little bit of experience of smiling and nodding. The rest of you will arrive at that station together. Map will go through the values and do some transformation to them. This works great for regular values. I will just kind of give a little bit of a spoiler. It becomes problematic when I heard you like observables, so I put observables in your observables. And that's where we're going to have to deal with some of that, but we're not totally there yet.
Okay.
It's got a little cousin called map2, which just maps it to a value. Map2 basically is effectively if you took whatever value it was and returned the same string no matter what. Map2. Cool. Map2 basically is effectively if you took whatever value it was and returned the same string no matter what.
Okay, so map to whatever string.
Map2. Cool. Reduce. Reduce is, there's two that are kind of similar, right? Reduce and scan. I want to point out the difference between the two of them. We'll look at scan next. Reduce will basically be like an array reduce, very much so where you will only get the final value when it's all done, right? So it'll work through all the numbers. In this case, it's totaling them up. It will add them all in place and then give you the final value. Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through, right? So if you want every, right? So it'll work through all the numbers. In this case, it's totaling them up. It will add them all in place and then give you the final value. Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through, right?
Every time it took.
So if you want every kind of piece as you go through, every value is emitted, you'll get it all along the way. Reduce will only give you the final result. So the reason that I point this out is scan is usually what you want, but your brain a lot of times, because of arrays, will think about reduce. So I'm like stopping for a minute and pausing to be like, nah, you probably want scan, even if you're thinking reduce in this case. Think about the result. So value and pass it through, right? So if you want every kind of piece as you go through, every value is emitted, you'll get it all along the way. Reduce will only give you the final result. So the reason that I point this out is scan is usually what you want, but your brain a lot of times, because of arrays, will think about reduce. So I'm like stopping for a minute and pausing to be like, nah, you probably want scan, even if you're thinking reduce in this case. Scan can theoretically, you can take an infinite range, you can scan through it, but then you take 4, so on and so forth. One final one, which is everyone's best friend, is tap. We said before, pipe, one value to the next value, so on and so forth, right? Tap allows you to kind of have a side effect for a second and then return the same value you received. Why is this useful? Because if you don't have tap, here's what you're going to do. You're going to map where you console log the value and then return the same value again. You don't need to live like that. You can just use tap, and you can console log the value. It's also useful for side effects that you want to do, because again, your subscribe will only get that final thing that comes out. It will not get any of the intermediary values, right? Yep.
In my understanding correctly, the top is essentially a convenience function where it takes in a value, operates on it, and returns that same value.
Yep.
Yeah, okay.
Yep.
In my understanding correctly, the top is essentially a convenience function where it takes in a value, operates on it, and returns that same value.
Operates on then return the same value.
Yep.
Yeah, okay.
Exactly. It's like, I want to do other stuff, but I don't actually want to change this value in any way, shape, or form. Keep it going through. I just want to, again, console logging alone is worth tap's weight in gold, even though it's code and doesn't have a weight in gold. But yeah, tap is useful for, I want to do something, a side effect of some sort, right? Because this pipe is, in functional programming, like it's a pure, a set of pure functions. Tap allows you to have a side effect. That could be console logging. It could be manipulating the DOM. Could be anything along those lines. Anything you need to do that's not going to be the final value can happen in Python.
All right. So that'll be all for this video. Take care.